All right, example 6. Find all the solutions to the equation cosine of x equals x, correct to 2 decimal places. What you're going to notice about this one, it doesn't say cosine of x equals 0. Cosine of x minus or equals x. So first thing I want to do is I want to move either x to the left or cosine of x to the right. It doesn't matter. The only difference is what the graph looks like. One might go like this. The other might go like that. I mean, one's going up, one's going down. They're going to cross 0 at the same spot. What we care about is where it crosses 0. So I'm going to take the x and move it over to the left. Now, be careful that it's cosine of x minus x. That this x is protected, that we're not subtracting the x's. And we want to make sure that we type in our calculator that we get that happening. So when I type in cosine, you can see that cosine puts that beginning parentheses of x. I want to put an end parentheses to stop the cosine function from happening anymore. And then I'm going to be subtracting x, and again that equals 0. So on your homework I would expect that step to happen. If your problem didn't start off as equals 0, I'd expect to see where you modified the function to tell me what equals 0. One other thing, and again, you haven't taken these calculators to physics yet, or used them in physics yet, maybe with degrees, but again, physics uses degrees, calculus uses radians. Anytime you want to hit the sine, cosine, or tangent button, it's a safe bet to check the mode to make sure you're in radians, not degrees. I would do that personally just to make sure. And go back to y equals, my function's typed in correctly. My zoom is going to be a standard zoom again. I always start at standard zoom when I'm trying to solve equations. Most of the answers are between -10 and 10. And there's my nice little cosine of x minus x function. And just to give you a visual, without me drawing in the air, if we'd gone the other route and did x minus cosine of x, it just gives an upside down version of the same graph, but they cross 0 at the same spot. So again, it doesn't matter if you take the x to the left or the cosine of x to the right, the answer's the same. It just matters, your graph might look different than somebody else's graph because they did it different than you did, but you're going to get the same result. The answer is going to be the same in both cases. Get one of those off of there. All right, so there's what I'm saying. And again, all I care about here is where it crosses the x-axis. If I can see where it crosses the x-axis, I got a good enough idea so I can do a left bound, a right bound, and a guess. I'm good to go. In this case, there's only one answer. All right. The only rules of left and right bound is they have to be within your window. If I'm going from -10 to 10, I can't guess a left bound of -50. All right? But if I go here to Calc 0, and I say left bound of -9.2, and a right bound of 8.56, and I guess -8.21, which are terrible guesses and boundaries, right?
Yeah.
There's only one answer. I'm saying it's between this and start here. My calculator is going to find the answer.
So you can say -1 in a million, and
Again, you have to be within your window. You can't go off your window. But as long as you're within your window, if there's only one answer, make sure you pick something way left, pick something way right, and it doesn't matter what you guess as long as you guess between.
if you set your window to that, you could though.
Yeah, I don't know why you'd want to, but yeah.
That'd be a.
And that says 0.739888513, I think. So x equals 0.74.